Good morning everyone. Myself Ramanjelu, working as an assistant professor from the Department of Mechanical Engineering in Annamacharya University. Today I am going to discuss about Carnot cycle in detail. What is Carnot theorem? How a Carnot engine works on Carnot theorem. Practically whether it is possible or not. In this lecture, we are going to get clarity regarding the same. Okay, let us start. What is Carnot theorem? No heat engine operating between two heat reservoirs can be more efficient than a reversible heat engine operating between the same two reservoirs. Before understanding the principle, let us discuss what is an engine. Engine is a device which converts chemical energy into mechanical work. So input energy is taken as heat and it generates output as mechanical work. In this diagram, you can observe heat engine is connected with one source and sink. For an engine, heat energy is collected from the source and waste heat is rejected to the sink. Some amount of energy collected from the source is converted into work and remaining energy is rejected to the sink. Let us see the difference between heat engine and a reversible heat engine. In the heat engine, we consider all type of losses, whereas in case of reversible heat engine, we don't consider any losses like frictional losses, conduction losses, convection losses, etc. So always the efficiency of heat engine will be less than the efficiency of reversible heat engine. He is the person Nicholas Leonard Sadi Carnot, who is called as father of thermodynamics. In this diagram, you can observe a cylinder and a piston, which is filled with the gas inside the cylinder. For this cylinder and piston arrangement, one source and one sink is connected, and you can also observe one adiabatic cover and a diathermic cover in the diagram. Source is used to supply the heat to the system and sink is used to collect the heat which is rejected from the system. Adiabatic and diathermic covers are used to replace one another according to the thermodynamic process involved in the Carnot theorem. Adiabatic cover restricts the heat to flow into the system or out of the system, whereas diathermic cover allows the heat to travel out of the system. Engine is going to work based on the movement of molecules present in the gas. When the heat is supplied, gas tends to expand, and when heat is rejected, gas tends to compress. Based upon this expansion and compression, the piston will be moving to and fro and the work will be generated. In this Carnot cycle, we are having four thermodynamic processes, that is 1 to 2 reversible isothermal heat addition, and 2 to 3 reversible adiabatic expansion, 3 to 4 reversible isothermal heat rejection, 4 to 1 reversible adiabatic compression. Let us discuss each thermodynamic process in detail. Here in this slide, you can observe four diagrams at the right side. In each diagram, we are going to discuss about each thermodynamic process, what is happened in the Carnot cycle. Before going to that, we should also consider some assumptions. Let us discuss that assumptions. First one, except one phase, all the phases of the system are insulated. So you may have seen the diagram in the before slide that all the three phases will be fixed and one side it will be open for placing adiabatic and diathermic covers. Second point, gas inside the cylinder will not come out, only energy gets transferred. That means it is assumed as control volume. The gas which is taken inside the cylinder will be as it is in the cylinder and it expands when heat is supplied, and when heat is rejected the gas gets compressed. Third point, in each process, diathermic and adiabatic covers are replaced one another. Let us discuss each thermodynamic process in the Carnot cycle. First one is reversible isothermal heat addition. Isothermal means keeping the temperature constant. We need to add heat to the system. In the first diagram, you can observe that yellow cover is placed in front of the piston arrangement. This diathermic cover helps to allow the heat into the system. During heat addition, the gas molecules will expand and the piston will be changing its position from one side to the other side. You can observe the piston movement in the next diagram. The second thermodynamic process is reversible adiabatic expansion. So in this process, diathermic cover is replaced with adiabatic cover so that no heat will be transferred in this process. So adiabatic means no heat transfer. Only expansion takes place because of heat addition in the first process. During expansion, the temperature drops from TH to TL in the second process. Because of expansion process, piston moves from one dead end to another dead end where mechanical work will be generated. Next, the third process is reversible isothermal heat rejection. In this process, again, adiabatic cover is replaced with the diathermic cover. The piston moves from another dead end to top dead end and transfers heat to the sink. During this process, heat is rejected to the sink by keeping temperature constant as TL. Next, 4 to 1 process, reversible adiabatic compression. In this process, again, diathermic cover is replaced with the adiabatic cover. So, adiabatic cover will not allow the heat to transfer from the system. Reversible compression takes place during this system. Let us observe how to plot the thermodynamic process on the indicator diagram. Here in this diagram, you can observe PV diagram, that means pressure versus volume. So this pressure versus volume indicates that the piston movement inside the cylinder. So how the pressure is varying according to the piston movement and how the volume is varying according to the piston movement. So if piston moves from top dead center to bottom dead center, expansion takes place. During expansion, what is the process carried out, and during compression, what are the process carried out? Here you can observe. Let us see 1 to 2 process. In the diagram, you can observe that heat is supplied during 1 to 2 process and temperature is kept constant. And second 2 to 3 process, it is expansion process where no heat is transferred. Similarly, from 3 to 4 process, heat is rejected where temperature is kept constant. And 4 to 1 process, again heat is kept constant and temperature increases from TL to TH. In the same manner, temperature and entropy diagram is plotted according to the thermodynamic process discussed. According to first law of thermodynamics, for any process, Q is equal to delta U plus W. Q means heat transfer. Heat transfer is equal to delta U means change in internal energy and W means work. So net heat transfer is equal to sum of change in kinetic energy plus work done. Let us apply the above equation for all the thermodynamic process individually. Here you can see in this slide, first process is reversible isothermal heat addition process. In the isothermal heat addition process, the internal energy will not change. That means U1 will be equal to U2. Therefore, Q will be is equal to work done. Net heat transfer will be equal to the work done. In the second process, reversible adiabatic expansion process. As the name implies, adiabatic means no heat transfer will take place. So heat transfer is considered as 0 and you can see the remaining equation, internal energy and work done. In the third case, reversible isothermal heat rejection process. As we are telling that heat is rejected and the sign of that heat transfer will be considered as minus. So minus Q2 is written and there is no change in internal energy. Therefore U3 will be equal to U4 and W as usual. In the third case, reversible adiabatic compression process. As again it is adiabatic process, no heat transfer takes place in the fourth process. Why Carnot cycle is impossible? Let us discuss few points related to the same case. All the processes in nature are irreversible. That means whatever the process we consider, there will be some losses and it cannot be reversible. That means there will be some frictional losses which need to be considered so that we can't regain the original process as we are having in the beginning. Second point, it is not possible to replace the covers, diathermic and adiabatic covers continuously. As the cycle is running with high speed, diathermic and adiabatic covers cannot be replaced within fraction of seconds, which is impossible. And the third case, isothermal heat addition and rejection requires infinite time. So as I said, isothermal process, keeping the temperature constant, we need to add heat to the system, which is a very slow process. Similarly, keeping the temperature constant, we need to reject the heat from the system, which also takes more time. So in the four process, two process will be running with high speed and the other two process will be running very slowly, which is not possible in a continuous cycle. Next point, frictionless motion of the piston is not possible. That means for any relative motion, there will be friction between two parts. So without friction, we can't operate any system. These are the few points why Carnot cycle is impossible. Thanks for watching.